For this example, we have a gusset plate that is subjected to the three forces shown here. We need to find the force in the member at C, which is labeled as T, as well as the angle theta, shown as the angle between these two pieces, B and C. So the first thing we're going to do to solve this is I'm going to find this angle between here and here. It'll be useful for me. So I need this angle, I'm calling it alpha. So the tangent of alpha is equal to 3/4, and that's because they gave me this 3, 4, 5 triangle. So the tangent, as a reminder, of an angle, I'm calling it alpha, is the SOHCAHTOA, opposite over the adjacent. So with this 3, 4, 5 triangle, the opposite is the 3 and the adjacent is the 4. So that's how we get that angle. And then the angle is then the arctangent of 3/4, which ends up being 36.9 degrees. So we needed that angle, and now we will draw a free body diagram of our system. We have our point, everything's concurrent on the point here, O. We have a 9 kilonewton force straight up in the y direction. We have this 8 kilonewton force acting down and to the left at this angle of 36.9 degrees. Our x-axis is here, and then we have this other force that we don't know the magnitude of. We're calling it T, acting down and to the right. And then finally this unknown angle theta, which is the angle between T and the 8 kilonewtons. So if I create my equations of equilibrium for this free body diagram, I have that the sum of the forces in the x direction is equal to T cosine of, and the angle here for this guy, to use the cosine, is going to be the overall angle theta minus my alpha. Theta minus alpha, 36.9 degrees. Minus 8 kilonewtons, this force, times the cosine of 36.9 degrees is equal to 0. Those are the two x components that I have. And I'm just going to solve that out just a little bit. We have 8, this is all values, so we can multiply that out, and we end up with T cosine of theta minus 36.9 degrees is equal to 6.4. We're just going to call that equation 1. Then we have the sum of the forces in the y direction is equal to my 9 kilonewton force, which is pointing all the way up. Then I am subtracting T times the sine of, again, that angle is theta minus 36.9 degrees. And then subtracting the y component of the 8 kilonewtons, which is 8 kilonewtons times the sine of 36.9 degrees, and set that all equal to 0. So again, I have this as a scalar value and this as a scalar value. So I can combine those to get T sine of theta minus 36.9 degrees is equal to 4.19. And we're calling that my second equation. All right, now we need to do our algebraic manipulations, or just solving algebraically, so that we can actually get t by itself and theta by itself. So what I'm going to do is divide equation 2 by equation 1. That gives us t sine of theta minus 36.9 over t cosine of theta minus 36.9 is equal to 4.19 over 6.4. And the reason I'm doing that is because I recognize that the tangent of theta is equal to the sine of theta over the cosine of theta. So that's what I end up with right here. I have sine over cosine, so I can reduce that now. These t's come out because you're dividing. So I have now tangent of theta minus 36.9 degrees is equal to 0.655. So that makes things a little bit easier for me. And now I can take the arctangent of both sides, and I have theta minus 36.9 degrees is equal to the arctangent of 0.655. So I multiply this, I can get that, add 36.99 to it, and I get that theta is equal to 70.1 degrees. So that's one part. And now I can stick that back into either equation 1 or equation 2. It doesn't really matter. So I'm going to choose equation 1. And then so I have t cosine of 70.1 degrees minus 36.9 degrees is equal to 6.4. And t then is equal to 7.65 kilonewtons.